Alright, we're moving on to Chapter 20E notes. We're looking at equations of tangent lines. So we're looking at equations of tangents to curves. So far we've talked a lot about slopes of tangent lines, the same thing as the derivative if we evaluate it at a point. We've also looked at how we can use our graphing calculator if you have some type of curve typed in and you graph it, that you can calculate the derivative at a certain point, just making something up, and it'll give you what the slope is of the tangent line at that point, or the value of the derivative at that point, or all the same thing. So all of these mean the same thing. Slope of the tangent line is the value of the derivative at that point. It's also the instantaneous rate of change at that point. It's also the gradient or the slope. Those are all the same thing. So we're going to be finding equations of tangent lines to curves. So they want us to find the equation of the tangent line to this at this point. I would like to graph it so I have a good idea of what it looks like, so I can kind of see what I'm doing. So in my y equals, I'm going to type y equals x cubed. Graph it. There it is. I want to make a tangent line at -2. So I'm going to plot my x cubed function. -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. So it sort of looks like this. I'm going to take a pencil and kind of sketch in the equation of the tangent line at this point. So -2, my function is down here. Remember, a tangent line is a line that intersects it at just that point. It sort of brushes the edge of the function, so it's going to look like that. Yuck, that's kind of icky. So it's definitely going to have a positive slope. It is increasing at that point. I don't know how positive. Looks pretty positive. Looks pretty much straight. It looks very straight up and down, but let's see how straight up and down. There's two ways that we can get the slope at this point. The first way is the more algebraic way. I'm going to go through that so you can see some of the connections. First way is we can find the derivative of this function. dy over dx equals difference in y over difference in x. Remember, we can take our powers and drop them to the front and decrease our exponent by 1. This is called the derivative function. The derivative function allows us to find the slope at various points along the line. So if I plug in x equals -2 to this, 12. 12, so -2 squared is 4, 4 times 3 is 12. The slope of my tangent line at this point should be a positive 12. Rise 12, run 1. Rise 12, run 1. We can also do this exact same thing on the calculator. I want to know the slope at x equals -2. So second, calculate. Number 6 is our dy over dx, which is our slope, at x equals -2. I just type -2 is all I do. -2, enter. 12.0001. It doesn't have has a hard time rounding. That's 12. So it gives us the same answer either way. Find the derivative, plug in the number that you're looking for the slope at, or you can use your calculator and find it from there. So my tangent line is going to go through this point on my line, the x equals -2 and -8, and then it's going to rise 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Run 1. I'm going to go off my graph, but it'd go 1, 2, 3, 4, 5, 6, and then 6 more. 7, 8, 9, 10, 11, 12, run 1. It's going to look something like that. Would be tangent at that point if it has a slope of 12. So now we have to go back to Algebra 1 where we write the equation of a line given a point and given a slope. So the point that I know is on the line is this point right here, -2, -8. It needs to be, I'm trying to find the slope at this point, -2, -8. If you look at my table, there it is. So that's that point. The slope is 12. So point is -2 to -8. Slope is 12. So we can take y equals mx plus b and plug in everything we know, solve for my y-intercept. So my y value is -8, my slope is 12, x is -2, slope is 12, x is -2, plus b. That would be -24. Add the 24 over. 8 plus 24 is, -8 plus 24 is 16. So now I have my b value. In order to write the equation of a line, you have to have your y-intercept, you have to have your slope. We have both of those. So the equation of my line is y equals 12x plus 16. 16 seems like a reasonable y-intercept because my point is all the way up here. Right, whenever I rose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 1, I was up here at 16. Seems reasonable. That's the equation of my line. Alright, let's try this again. Same steps. Find the equation of the tangent line to this function at this point. And graph the original tangent line. Then find the point at which the tangent line meets the graph again. So first, I'm going to graph this function to get a visual idea of what I'm working with. X cubed plus 1 over x. There it is. I'm going to graph this by going second table. Ooh, I have fractions. If you get fractions, just let me know. I can show you how to fix that. That should fix it. Let's see. If it doesn't fix it, we'll just have to work with it. It's been fixed. Okay. So here's our decimal values. The fractions would have been the same, just harder to... So -2, -8.5. -1, -2. At 0, we have an error. Okay, that gives us a vertical asymptote. 1, 2, 2, 8.5. Seems like a little bit of a weird line here. So if I look at my graph, it looks like it's going up and then back down pretty quick. And then it's going down and back up pretty quick. Okay. We could find the derivative and then find the slope from there. I want to work efficiently. So instead of finding the derivative, why don't I just go second calculate dy dx. I want the point at x equals -1. -1, enter. Tells me the slope is 2. Alrighty. The value of the point at -1, if we look in our table, -1, -2 is the point. So this is the point, -1, -2. We need the whole point in order to do the process of finding the b value. So we got our point, we've got our slope, we're ready to find our y-intercept. So I'm going to plug everything in to y equals mx plus b. Plug in the point for x and y, plug in the slope for m. So the y value of my point is -2, slope is 2, the x value is 1, x here, slope there, y there, plus b. So we get -2 equals -2 plus b, add the 2, and b is 0. So my equation, I have a 0 for my b value, is y equals 2x, because this was my slope. Plus 0, we don't need that. So if I go to the point -1, -2, the equation of the tangent line at that point, they are saying, has a slope of 2. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Kind of like that. Now, this point kind of looks like it's intersecting there, but I'd like to be more precise. This is a very sketchy graph. So let's see how we actually did. So in my y equals, I'm going to type 2x, which is the equation of my tangent line. Graph it. You can see that line is similar to where I put it over here. Slope of 2, it's increasing. I want to see where it intersects again. We can find intersection points sometimes from our table, and sometimes we have to use our calculate button. So the points they share, -1, -2, but we already knew that. And then here's the other point, 1, 2. They share this point. So that's the second part of the question. Where does it intersect the graph again? If it didn't show up in our table, we'd have to go second, calculate, intersect, and then we'd have to scroll over till we get right close to where they're intersecting. Enter, enter, enter. Ooh, it's really thinking. I might have stumped it. Let's see. Iterations. For some reason, this is making the calculator kind of grumpy, so the only way to fix this, it's going to be to zoom in on the point where we think they're intersecting. So I'm going to zoom, moving my little dot so I can select where I want to zoom into. I want to zoom into right there. I guess the calculator needs a little help. It needs you to get a little closer so it can see. Second, calculate, intersect. Let's see how it does this time. See if zooming in once fixes it. Ooh, not looking good. Try zooming in again. I got it to work a little while ago. Let's see if that works this time. Yay, there it goes. So it looks like 1, 2. So typically that works a little easier. I don't know why that was so difficult this time. But it does intersect again at 1, 2. All right, let's do one more. Find the point where the tangent to that curve at this point meets the x-axis. So let's graph this equation to get an idea of what we're working with. So I'm going to go to my y equals 3x cubed minus 2x plus 1. Graph it. Oh, I'm way zoomed in. I'm going to go zoom 6 is standard. There it is. I'm going to sketch that line by going to my table and plotting the points. Ooh, -1, 0, 0, 1, 1, 2, and then the rest are way off there. It does have a little squiggle in the middle, though, that we want to make sure to capitalize on. So it looks like that-ish. They want us to find the point where the tangent to this curve at x equals 1. So x equals 1 is this point here. I can tell that my graph has a positive slope at that point. It is increasing, so I should expect to get a slope that is positive. The algebraic way, just to kind of go back and remind you of that, because you might need to find the derivative on a problem like this on your IB exam. We find dy over dx. We use the power property to do this, so move your exponent down to the front. 3 times 3 is 9. Drop your exponent by 1. Your exponent on your x has a 1 here. 1 times -2 is -2. Those x's go away, and we always ignore constants for our derivative. So this is our derivative function. We can plug in 1 to get the slope at that point. 9 times 1 squared, that's going to be 9, minus 2 is 7. I would always, even if I needed to show that work on an IB test, I would always double check. Calculate the derivative, x equals 1, and oops, I'll show you again. We get 7. So derivative, 1, enter, 7. Check. So I know the slope. I also know the point that it goes through. So they told us x equals 1. This point is 1, 2. Sorry. And so we're going to use that point and this slope to write the equation of the tangent line. So my equation is y equals mx plus b. Y is 2. My slope is 7. X value is 1. 7 times 1 is 7. Subtract it over. So b is negative 5. That means the equation of my tangent line is y equals, slope is 7, x minus 5. The question asks us to take that tangent line and find where it intersects the x-axis. Find the point where the tangent to this curve at that point meets the x-axis. I want to figure out where this line crosses the x-axis. We have a calculator that can help us. So I'm going to graph 7x minus 5. There it is. I want to find the point where it meets the x-axis. Now, if you want to, you can kind of see it is tangent at that point. I would like to just get rid of that original, so I have less to look at on my graph. It makes our next calculation a little bit easier. We can calculate the 0, which is the place where it intersects the x-axis. So remember, this is the left-right bound. It says left-bound, left-right bound situation. So you go to the point, and you want to go to the left of it, enter, cross over it until you're on the right. Doesn't matter really how far. You can go really far, you can go not very far, it doesn't matter. Enter, enter, and it tells us that the 0 is at 0.71428. So where does it cross the x-axis? 0.7143 is the point. Algebraically, this is where the point where it crosses the x-axis is when y is 0. So you could also do 0 equals 7x minus 5, add the 5, divide by 7, and 5/7 should give us the same decimal, which it does. So that would be your alternative option, if you would like, would be to solve for when y is 0. That's for your x-axis intercept. For your y-axis, you would plug in 0 for x. All right, thanks for watching. This gets you ready to go through. Chapter 20E. Chapter 20F will be in a separate video. Thank you for watching.